You're listening to the B&H Photography Podcast. For over 40 years, B&H has been the professional source for photography, video, audio, and more. For your favorite gear, news, and reviews, visit us at bnh.com or download the B&H app to your iPhone or Android device. Now here's your host, Alan White.
Greetings and welcome to the B&H Photography Podcast. On August 21st, 2017, we're going dark, or at least 71% dark here in Manhattan, according to my notes. The reason, in case you don't know, is we're going to be having a solar eclipse. On today's show, John Harris and I will be joined by our comrades in arms and lenses, Todd Vorenkamp and Christopher Witt, and we'll be talking about the best places to see the eclipse as it sashays across the United States, the safest ways to watch the eclipse, the best camera gear to photograph the eclipse, along with a few tips on how to get the best results from your gear. In the second half of our show, we'll be joined by Professor of Physics and Astronomy, Tyler Nordgren, and Dr. Laura Petit, a senior fellow at the Space Sciences Laboratory at the University of California, Berkeley, and director of Multiverse, the Space Sciences Laboratory's education group. Tyler and Laura will offer their expert opinions on viewing the eclipse, and Laura will discuss the Mega Movie Project, which is being produced in affiliation with Google and will capture the eclipse from coast to coast. Before we flip the switch, a short plug for our show, which can be found on iTunes, Google Play, Stitcher, and Android. Subscribing to the show on any of these platforms is the best way to enjoy and to support our show, and it's absolutely free. Also, if you haven't already done so, visit our landing page, www.bhphotovideo.com/explorer/podcast, where you can find all of our past shows with additional text and photos to go along with each episode. All right, now, in recognition of the millions of people who will be viewing the solar eclipse in August, Al's Gearhead Pick of the Week provides one way to view it safely. The Meade 10x50 Eclipse View binoculars with solar filters. These feature BK7 Poro prisms, removable white light solar filters. They could be used for conventional or solar viewing, which means you could use them after the eclipse and before. They have large rubberized center focus wheel, anti-reflection, coated optics. It's tripod mountable with an optional adapter and has fold-down rubber eye cups. Last but not least, slip-resistant rubber armoring.
Ooh, fold down tight.
Anyway, it's a great, inexpensive. I think it was like $50 or something like that.
Yeah.
It's great, and also you have yourself a nice pair of binoculars before and after the big show.
What's really nice about those is that the large objectives and the magnification gives you a really wide exit pupil. So during the nighttime, and especially during the eclipse, when it's moving towards totality, the light will completely cover your eye, so you won't have any vignetting or any interference with the views of it. So you have a really great exit pupil.
Is there anything else besides the filters that make this specific to an eclipse?
No, the filters are what makes it useful for the eclipse and general solar viewing. What makes the exit pupil important is that as it gets dark out, your pupils dilate and get bigger. So if you have a small exit pupil, the light coming through the binoculars won't cover your dilated pupil, and you won't be able to see the entire scene. So when at night, if you're using it for astronomy, regular conventional astronomy at night, you want an exit pupil that's going to completely cover your fully dilated pupil.
Cool. But most important, your optic nerve won't burst into flames if you should look.
Cool. That's the other part.
That's
it. Most importantly.
Most important. Well, we've already heard from Chris. Welcome, Chris.
Hello.
Christopher Witt is the senior technical writer for optics at B&H. He has over 20 years' experience as an outdoor enthusiast, nature watcher, and amateur astronomer, as you can already tell. And if you need to know anything about binoculars or telescopes, he is your go-to guy. Also joining us today is our podcast veteran, senior creative content writer here at Explorer, Todd Vorenkamp. A photographic artist for 30 years, Todd has a Master of Fine Arts from the Academy of Art University and is a former U.S. Navy and Coast Guard helicopter aviator and a licensed merchant marine officer. You might have noticed if you're ever here in the morning or afternoon on West 35th Street, a hovercraft coming down the street. Okay, that's Todd. Okay, he's good.
Or the cyclist that's yelling at you because you're doing something wrong.
Hovercraft or bicycle. That's going to be Todd. You can find
I mix it up.
You can find his writing and photography at B&H Explorer and on his personal website, which is www.trvphoto.com. Let's start with Chris. Tell us some of the basic facts of the eclipse, and how do you recommend viewing it?
Well, as you said earlier at the top of the show, it's going to happen on August 21st of this year. It's going to be traversing the entire...
That's a Monday, just FYI.
Monday.
Right?
Yeah.
It's going to be traversing the
the day
entire
off.
country from coast to coast. And it's
Starting on which side? West Coast?
West Coast.
Starts West Coast.
West
Okay.
Coast and heading east, southeast specifically.
Uh-huh.
So it's going through, I think, 7 or 8 states completely or partially. And that's where the path of totality will be occurring. That's where 100% solar eclipse will be occurring. Outside of that, everyone that lives in North America, well, United States, Lower Canada, Upper Mexico, are going to be seeing a partial eclipse of some sort. And where you are in relation to that path of totality will dictate how much obscuration you'll be seeing.
And from what I looked at the map, it's kind of it really is cutting through the center of the country.
It is, yeah.
So the center of the country, you're going to see more. The further north, further south, you're going to see less.
Yeah, it's basically going from Oregon diagonally to South Carolina. So
With a slight curve.
with a slight curve.
I've survived 2 eclipses over my years. I don't think I've ever been in a total solar eclipse. How dark does it actually get?
It gets like nighttime. You'll be able to see planets and stars when you normally wouldn't.
Even when you're not in the full totality?
No, anyone out of path of totality, it will get sort of twilight,
yeah.
twilightish.
Yeah. It's an interesting light because people think it's like a sunset or something like that, but it's really not. The color temperature doesn't change. The shadows don't change. It just gets dim.
It gets dim.
It's real weird. It's
Yeah,
a very
it-
strange
There's,
Yeah,
no,
it's like-
there's no golden hour. There's no twilight.
Exactly.
Yeah.
No, it's like someone's turning a dimmer switch down on the world
Right.
for a period of time.
Yep.
So, it's not go outside 5 minutes beforehand, take a look, and then go back inside. It's a big event that bring long chairs and and stuff.
Hot
And,
dogs.
I mean, I kind of wanted to get this later, but because we're here, where are the big parties? I mean, I know it's going to be passed through a few or close to a few major cities, and I know people are going to some cities and hotels are sold out, and there's going to be probably events everywhere it goes. But which is there any 1 or 2 places that are going to be?
I don't
main
think that
draw?
there's really like a destination spot, a single destination city that you need to be in. Basically, anywhere that you're in a path of totality is going to be a party.
Yeah.
And I mean that in a very literal sense. It's going to be cars honking horns and people going crazy and
Catching
champagne
dogs.
being
Right.
popped and the whole nine.
Right. Well,
From a practical standpoint, just outside of Nashville, sort of between Nashville and St. Louis, there's going to be the longest duration of the eclipse, which is 2 minutes, 40.1 seconds. And
you got the 0.1 in there.
yes, I'm very specific with my stats. So that's where the greatest duration of the eclipse is going to be. So if there is a sweet spot, if there's someplace that you need to be, then I would say that's it. It's about 100 miles outside of Nashville.
and just to kind of throw this out there, B&H, and I'm sure many other sites, but B&H has you can just Google B&H and eclipse, and I'm sure you're going to come up with a map. It's up there.
Right.
So take a look. I mean, Chris has a pretty nice list here of cities that it's going to be near the path of totality. I'm going to read off a few: Redmond, Oregon; Stanley, Idaho; Troy, Kansas; Kansas City, Missouri; East St. Louis, Illinois; Blue Ridge; Dillard, Georgia; Lexington, South Carolina.
The eclipse is passing directly over Jackson Hole Airport in the heart of the Grand Tetons. So if you want to have some beautiful scenery to look at before and after the eclipse, that's a good place to go.
And if you're going to be in South Carolina, my brother and sister-in-law live there, and I could put in a word for any of our listeners who need a place to stay.
Yeah, totally.
Okay, Fern, Dogfish, just giving you a warning, okay? You might be getting some calls.
All right. And then what about for New York? I mean, what's going on here?
Well, for New York, we're going to get 71% obscuration, which is still pretty good. It's anything, and I can't stress this enough, unless it's the actual couple minutes during totality, you need to be wearing some kind of ISO certified protective eye gear for looking at the sun, even during a partial eclipse, especially during a partial eclipse when you think, wow, it's really dim out. It looks like I can look at it, and then all of a sudden you're blind.
Is it safe to assume that standard regulation sunglasses are not sufficient for looking at?
That's right.
Yes.
Okay.
That's right.
How about if you wear 3 pair?
No.
Still probably not.
Yeah.
What about, and seriously, what about neutral density filters? Say you have your photographer has neutral density filters, 2, 3, 4 stops. Where do we start with that? Todd, take over.
If you look at
I thought this was my portion of the show.
Okay.
Oh, right, well, yeah.
now we're hijacking each other. All right, I see how this is going.
So, most official organizations say do not use a neutral density filter for photographing the sun. However, there are a lot of new filter companies that are making neutral density filters that are strong enough to do solar photography. The big asterisks next to this is you're going to only use those new ND filters with an electronic viewfinder or live view on your camera. You're not going to actually look at the sun.
Mm-hmm.
I haven't read this, but my theory is it's not blocking the damaging wavelengths.
That's right. You might be able to stare at it, but there's stuff that we can't see that still get
That's exactly what I was going to say.
Yeah.
These ISO certified glasses that I have handed out to the studio here for us to look through.
Hold one up to the camera.
Oh, hold on, let me get that. So
it's great radio, boys and girls.
On the back of the glasses, it clearly states that these are ISO certified for viewing the sun with your naked eye. So to your point, using a neutral density filter, it's not going to block the UV and IR radiation, which is what's really going to do the damage if you look at the sun with the naked eye. The photoreceptors of your eye don't have pain sensors. So you can look at it and kind of blow out your retina, but the damage is done by the radiation, the ultraviolet and UV radiation. A neutral density filter is not going to have a UV and IR block on it.
Let me just jump in here with that, because there's so many times we've kind of glanced up the sun and we squint and we do like that. How come we're not getting that damage at that time?
Because it's a split second.
It's just so there is a kind of a
and your
time
eyes
aspect of it,
automatically blink. Your eyes
Technically, you probably
down.
are. Like if you're an outfielder and you're chasing a fly ball and it goes right through the sun, you don't blind yourself, but you're probably done in that fraction of a second. You've done some sort of damage.
All right, Chris, let's talk a little bit about your kind of specialty. How, if you want to view it, and we're not just. I mean, obviously, let's be clear. Be safe. Don't look at the sun.
Yeah.
Wear your glasses.
Yeah.
Special glasses that you need to buy. But if you were taking it to the next level, if you want to use a telescope, and there's other ways to view it, why don't you kind of give us a little breakdown?
Well, there's going to be 2 ways of looking at the sun and observing the full solar eclipse. So the most popular way, and it's going to be the way that I'd say 80 to 90% of people observing this, of the 350 million people in the United States that are going to be looking at part of this eclipse, is white light. And that's basically broadband viewing. So think of filtering out about 99.999% of the sunlight and just leaving a little sliver that you can see. And it's going to be across all wavelengths. So the whole Roy G. Biv thing, that's what you're going to be seeing. You're not going to see a lot of detail. It's basically going to look like a white or maybe a orangish disc. Depending on if you have magnified optics of some sort, you might be able to see sunspots, that kind of thing. So typically you're going to be using a white light filter, which is just blocking out most of the visible light, all of the ultraviolet on one end of the spectrum, and all of the infrared on the other end of the spectrum.
And that's a filter you would buy for your telescope.
It's a filter you'd buy for your telescope. It's going to be the sunglasses that you buy specifically for solar viewing. It's generally going to be a Mylar film, not dissimilar from the Mylar balloons, but it's a special kind of Mylar that is ISO certified, and it looks just like a crinkly film, and it's stretched between a housing or some kind of ring. It will most likely, it'll have wrinkles in it. That's typical. It's not a defect. What that does is it stops it from ripping, because it gives it a little bit of play. Some people will say that those crinkles will help add contrast and will improve the view. It's important, though, if you're using one of these film filters, that before you stare directly at the sun, you want to make sure that there are no pinholes in it, that's not ripped. Because, again, if you throw those glasses on and look through them to look at the sun, or you put it on a 10 by 50 binocular and go right at the sun, you're putting all that sunlight right into your eye.
That's a laser at that point.
That's exactly right. So you want to make sure that your filter is clean, that your filter is not defective, that doesn't have any pinholes. So you just want to hold it up to a light bulb and get pretty close to the light bulb, and you'll be able to see it. You'll be able to discern it through the filter. But more importantly, you'll be able to see bright little pinpoints. If you see those pinpoints, throw them away, get another pair.
Now, how much do one of these cost? And I'm assuming B&H is selling them.
We sell, places, yeah. Everyone is making them. Most of the solar gear that we sell will include at least one pair of these just as a free gift.
Oh, you're talking about the glasses.
Yeah,
I was talking about more of the filters. Like, I guess it depends on the size, of course, but.
The filters, like we were talking about the binoculars at the top of the show, those come with removable solar filters. You can get paper ones that come in a flat package that you basically fold together to make a ring. And those will be $12, $13. And throw them on any pair of binoculars up to probably 50, 60 millimeter objective size. Throw a rubber band around them to hold them in place and you're fine. You can get metal ones, metal rings with glass filters. That'll run you $50. But those are a little bit better. They won't be prone to ripping. They might give you a little better views.
Okay. Now, taking us to the next step here, narrowband viewing?
Narrowband, yes. What a narrowband filter does is it looks at a very specific wavelength, not much more than a few atoms wide. And since hydrogen makes up the most of the sun, the most popular is in the hydrogen wavelength. And what a hydrogen filter does is it takes everything out except for a very super narrow band and just lets that pass through. Those filters you can get for astronomical telescopes that you can add on to them. You can get ones that are built with the filter built into the telescope. You can get them for cameras. Todd and I are going out and doing some solar photography tomorrow with a hydrogen alpha filter specifically for Nikon cameras.
Mm-hmm. And what's the advantage of that?
It reveals a lot more detail than you would normally see. So if you think of a picture of the sun where you see the prominences shooting out into space, you see all that granulation, that surface wrinkles and stuff like that, that's all been taken with most likely a hydrogen alpha filter, matted, set up in after post-production and manipulated. But those pictures, those really awesome shots of the sun with the flares and everything, those are done with narrowband filters because you need to filter. The problem with the sun is that you have too much light. So you need to filter out as much as possible. So doing a narrowband filter really allows you to target a very specific wavelength and a very specific band in that wavelength to really show all the detail.
When we're down here, we have what's called 5,600 degrees, daylight. The visual spectrum is what, 3-something to 800-something nanometers or something.
Mm-hmm.
How does that relate to when you're actually photographing the sun? Is it the same color space? I mean, how does all that work?
Well, the hydrogen alpha band is red.
Okay.
So it's going to be in the 800s.
Okay. All right.
So basically you can get white light filters for spotting scopes, binoculars, glasses just for your naked eyes. And these will go right onto the top of any conventional telescope, binocular, spotting scope. The targeted wavelength will similarly work. Similarly, they go usually in the back of the telescope, and they don't make them for spotting scopes or binoculars. It's really just telescopes and this one that works.
This is for people who are getting really into it, or
yeah. The camera quark that will be from Daystar Filters that we'll be using tomorrow runs $1,500.
Yeah.
So, and that's just
Not
before
for the casual observer.
No, and that's before you even get the lens in the body, just for the filter. So this is all for looking at the sun. If you want to automatically track the sun, if you're planning on setting up a rig, you can do any binocular that has a tripod mount on it with a simple adapter. You can put it on just about any photo tripod. You would probably want one with a control handle, something, a pan tilt, a fluid head, so you can track easily. You can do go-to mounts that are really popular these days that have automatic tracking, alignment procedures, and stuff like that. Most go-to mounts will offer solar tracking as a speed because the sun moves fairly quickly. The sun moves at a different rate than the moon does because the moon is so close.
Mm-hmm.
Deep sky objects move at a slower rate because they're much further away. So most go-to mounts will have solar rate as an option. It will not have the sun as a easily findable object for obvious safety reasons. So if you have a go-to mount, you need to read the instructions, and generally somewhere in the setup or settings menu, there will be an option to enable the sun as a findable object and enable solar tracking just as another level of safety to make sure that your kid doesn't go out there, accidentally hit the sun and blow his eyes out.
Yeah. I guess we should stress again the fact that, you got to be careful about this. This is not just, you don't just go to the picnic and stare up at this thing. I mean,
no,
or point a telescope or
point a telescope
binoculars.
and look at it.
Yeah,
even
there's
worse.
So what will you be doing? What are you going to do specifically on the day of?
I've been thinking about this for a year now. I recently got the Skywatcher Virtuoso from B&H, and this has a tabletop mount that I'm going to put on my picnic table outside, right on my back patio. I have the SynScan controller, which is an option that you can get afterwards. It's not offered in the package that we sell, but you can get it from the manufacturer. And by the time the solar eclipse comes, we might be selling it. That will have the sun.
Maybe the day after.
Probably the day after. It has the sun as an object.
On special.
On special. It has the sun and solar tracking capabilities, but most importantly, the telescope itself comes with a white light solar filter. So I'm going to be outside. If I can get my Carson hookups to work correctly with my eyepiece, I'll probably be digiscoping through the eyepiece. That way I don't have to be hunched over my telescope. I can just look at it through my phone, snap some pictures, take some video, post to social media, that kind of thing. But most importantly, I want to be watching it. I don't want to be worrying about.
Now, are you buying special glasses, or are you going to use these the kinds that we have here? Just so people know, they look like the old 3D glasses you get at the movie theater.
That's exactly right.
They're just cardboard with the ISO.
They're well
filters.
perforated though. The folds are very well
very
done.
Nice.
Yes,
very nicely done. But you have, I guess, a pair that's a little more legit.
I have a Lunt 6x30 solar binocular. I think they call them sunoculars, and they are excellent. They give a little bit of magnification versus a regular solar glass like we're using here. Gives you some magnification. The objectives are small enough that you can easily hold them with one hand, and that's what I'm going to be doing for probably majority of the beginning of the partial eclipse, and then the back end of it. For the middle part, where it's going to be the biggest obscuration, I'll be looking through the telescope.
Cool. Is there a way of actually programming one of these advanced telescopes to do just the entire tracking, so you could just set it up and then just enjoy the show in real time?
Yeah, that's what I'm going to be doing.
Yeah, okay. All right.
And let's say you're not as advanced as you are, and you're not going to be in your backyard, or you don't have a backyard. What would you advise people to do? I mean, are there going to be, I don't know, astronomy clubs having viewing parties or things like that? Do you know about?
Most astronomy clubs, and there are probably more than you think out there. It's a huge hobby, and
Oh yeah.
And the people who are in astronomy clubs love to talk about astronomy, love to talk about their astronomy clubs, love to talk about their gear, and love to share their gear.
And love to have people say, take a look.
That's
come.
exactly right.
Yeah, it's very social.
Yeah. So I would say if you're in the path of totality, if you're going to be in Nashville, if you're going to be anywhere near that 2 mile wide path of totality, contact your local chamber of commerce. Check out local astronomy clubs. They will be doing something.
Universities, I'm sure.
There will be no shortage of things to do if you're in the path of totality. Outside of that, I would definitely recommend talking to local astronomy clubs. I know that Long Island Astronomical Society will probably be holding events.
Back in '74, I remember we were in Central Park, and a lot of people had telescopes. It was just all over the place. We had a choice of them. It was really kind of a lot of fun. Right. Question: say one of our listeners does not have a telescope. They're not going to be buying one, but they do have photographic gear. What focal length lens would you recommend for photographing it with a conventional camera system?
Depends on how much of the corona you want to capture.
And the corona is? It's not a beer.
The corona is not a beer.
A commercial.
No. Nope.
Okay.
The corona is the outer area of the sun that's invisible at all times except during a total eclipse. And the sun is a ball of fire. The flames extend past the surface. So when there's a total solar eclipse, you can see the corona.
Okay. Also called the Ring of Fire, I think, or is that something different?
That was during an annular eclipse where the moon is farther from the Earth. It does not cover the entire sun at the maximum point of the eclipse. So you get a ring, literally a perfect ring around the moon.
Gotcha. Okay.
But this eclipse is going to be a total eclipse where the moon is closer to Earth, and it's going to block out the entire sun, except for the corona. The great thing about the eclipse, you can use almost any type of camera that you have, including your cell phone. The results will vary. So I would say the best rig to get the best eclipse photos is a DSLR or mirrorless camera with a long telephoto.
How long would you want to go?
I would go at least 300 millimeters.
Okay.
On APS-C, the crop factor is going to make that a 450 millimeter lens. That's going to make the sun a fairly good size in the frame, and then you'll be able to capture all the corona. For point of reference, if you want to test your gear without pointing at the sun, point your camera at the moon.
That's a good idea to test it, yes. Because
of our cool solar system, the sun and the moon are almost identically sized in the night and day sky. So a lot of people, you think the sun is huge because it's like a massive point of light. It's actually the ball of it is literally the same size of the sun.
And this is something Chris wanted to mention earlier, sorry to cut off, but practicing ahead of time is something that'll definitely be to your advantage when the day comes, right?
I can jump to that. Don't think that you're going to be good at solar photography right out of the box. I mean, the sun is bright. It's challenging to aim your camera because you can't look directly at the sun to aim it.
And it's moving fast.
It's moving fast. If you have an extreme telephoto lens, you have a very small target in a bright white area. So, I mean, it's tricky stuff. So you have to practice, because what you don't want to do is on the day of the eclipse have brand new gear and say I'm going to just figure this out while I go. Because
I'm practicing every weekend to make sure that I know exactly how my telescope likes to be set up and how the mount works, how accurate the mount is for tracking, so that I can, on the day of the event, everything was going to be second nature. I don't want to be surprised at all. I want to be able to enjoy the eclipse.
I know I once did a series on the full moon with a 500 millimeter lens.
Yeah.
And it's pretty impressive how fast, once you get the moon in focus, it just sort of slips off the frame.
Right.
So yeah, you do need to practice because again, you're not dealing with a sitting target. It's moving.
I've done a lot of lunar photography, and that's challenging. The sun is like a whole nother ballgame because of the problems of aiming.
Now, is there any issues with the sensor of your camera?
So the next thing you're going to need for whatever camera you use,
borrow your friends to do this.
Right. Borrow your friends and make sure he doesn't want it back. No, you need a solar filter, and usually it's a screw-on filter that goes in the front of the lens, or a Mylar filter, or even people use number 14 welding glass sheets. They put that in front of the lens, things like that. So there's different concoctions to do it, but you need to protect the lens and you need to protect your sensor. We did it. We tried to debunk the myth. I pointed a camera at the sun a couple months ago here at B&H, and we could not damage the sensor. Having said that, that was one camera on one day in New York City. Your sun might be different. Your camera might be different.
Your sun may vary.
Well, it's also going to be in August.
Yeah, it's going to be August. Might be,
February.
so I don't take any chances. By the way, if you point an unfiltered camera at the sun, you might not destroy the camera, but your photo is going to be all white, and you can't get a photo of that, right? Yeah. You got to dim the sun. So.
And you can't fake it in Photoshop.
No, you can't. You're not going to be able to pull highlight detail out of that white frame. You can use a point and shoot. Like I imagine a lot of people that have that Nikon P900 with the 2000 millimeter equivalent lens are going to put a filter on the front of that and do some really cool stuff.
And one of the things I found, I don't know if it's the same thing, but I found with an older generation it might have been a P500 or so, I was getting a lot of lines. Whenever I had point to light sources in there, I was getting all kinds of strange digital artifacts happening. And I don't know if it's been corrected yet, but that could be an issue with some of the point and shoot cameras, where because of the small size of the sensor, the rays might just start doing weird things in the image.
Yeah, I mean, I have not done it.
Yeah, that's the whole thing. Don't buy and go out, on that day.
The sun is going to be in the sky before the day of the eclipse, so there's plenty of time to practice.
Yes,
that works.
Yeah,
and what about for all those folks that are going to be like grabbing their phone at the last minute and throwing it up there?
And you can do that. The other thing to notice is during totality, you don't want a filter on your camera because it's going to be dark. It's going to be basically going to do a night photo. So you can point any type of camera at the total eclipse and take a photo. How big that sun and moon are in the frame is depending on what your focal length is. On a cell phone, it's going to be pretty darn tiny.
Mm-hmm.
So I have a question that I think I know the answer to, but I'd rather...
Are you testing me?
I am, maybe a little bit.
For $5.
How well will autofocus work with these Mylar films when you're trying to photograph the sun?
That's a very good question.
That is a good question. I've actually, all the times I've done solar photography, I've done it manual focus. I would imagine, I think it'll probably work fine with a couple, I'll say this. So when you put a Mylar or a solar filter on your camera, you get a very crisp disc. The ball of the sun is a disc. So if you put a focus sensor on the edge of the sun, the autofocus should work. I don't see why.
Why would you even need to autofocus?
Wouldn't it make more sense to just shut that? There are times when you turn off autofocus.
Yeah.
Again,
this is infinity.
We're kind of at a fixed distance here right now, but a lot of weird things could happen because of the fact you're dealing with the nature of the subject. Your focus could start just playing around.
A lot of people recommend targeting your camera a day or two before the eclipse, putting gaffer tape on the focus ring so you can adjust the focus and leaving it there. Not very many lenses these days have hard stops at infinity, so
I was going to say, don't trust infinity at all. Right.
You can try autofocus. If it doesn't work, just go manual.
Yeah. So what are you going to be doing on that day, and what's your gear setup going to be?
My plan is to go to Nashville. There's a 50% chance of clouds, so let's all the listeners.
Are you really looking at advanced?
Yeah, I'm looking at the
really
the 6
You're
month
looking
forecast.
To weather forecast.
Well, he got the Farmer's Almanac, and that thing is spot on always.
Actually, people are using the Farmer's Almanac to plan their trip for the eclipse because, the Grand Tetons is a 20% chance of clouds. Nashville's a 50% chance. So hedge your bets. Where do you want to go?
So you went to the worst spot that you could go.
I went to a coin toss cloudy spot. So let's hope it's not cloudy.
What you're saying is the airfares were cheaper there.
You get a lot more fun in Nashville afterwards. If it doesn't
That's
work
true.
out, right?
You can have barbecue if it's
part of me wishes I went
cloudy.
Went to a more scenic destination. Not that Nashville's not, but the good news is my hotel is at the airport in the path of totality. So I literally can just walk out into the hotel parking lot and do the photos. So if the traffic is nuts that day,
which it will be,
or if there's clouds to the west or east, I can just.
And what are you gonna have? What are you gonna be shooting with?
So right now I have a Nikon 300 millimeter f4 lens that I'm planning on using. It's portable. It's lightweight. I'll get the sun will be a good size in the frame, and I'll get the Corona. That's my plan. I have a couple white light filters that I can play with.
You bring the spotting scope?
I probably won't bring the spotting scope because I have a Leica Televid 77. That gets me out to the equivalent of 1,500 millimeters, and the sun would basically fill the frame.
That's too long, really.
Yeah, it's tough to aim. I might bring it. I don't know. I haven't finalized my plans, but yeah, I can't man two cannons at the same time.
What's the enthusiast photographer who has a DSLR and let's say 70-200? What do they need in order to make this happen?
A solar filter.
That's it.
That's it. Yeah, and even like if you have
tripod.
If you have a Nikon D5500 or a Canon Rebel and a 70 to 300 or a 75 to 300 lens, you're pretty good at that 300 lens.
And what about
300 millimeters.
what about your exposure settings?
It depends.
You have to change from throughout, right?
I've photographed one eclipse in my life, and it was a partial, and it was through clouds. So I'm not a proven expert, but Fred Espenak, who's Mr. Eclipse, has an exposure table, and it basically gives you an exposure for the different parts of the eclipse, like the Bailey's beads, the golden or the diamond ring phase, and then totality. And he shows different exposures for different regions of the corona. So what most people do, and most people say to do, is just bracket the heck out of your images. Have your camera aimed, start shooting, and roll through different.
So if you have an auto bracketing feature on your camera, this is a good time to use it.
Yep. If you've never used that before, practice with it. And
and what about film photography? Is there any advantages or disadvantages, or any thoughts on that?
The disadvantage is you won't know if you got it until the next day. The advantage is you can tell people you shot on film.
One last question that I have as far as gear. Would a fluid head make more sense on a tripod than a traditional, say, tilt shifter or ball head in this case?
I think
Right?
so, depending on the size of your lens. If you have a monster telephoto, you're going to want a gimbal lens.
Yeah.
But if you have a kit lens or that 300 f4, I have a fluid head that I use on a spotting scope. That might be my head for that day because I'll be able to
that would
track
make
it a little
most
more
sense
smoothly.
to me. Just a
Are you planning on bringing a tripod?
Yes, I'm definitely going to bring a tripod. You want to have a tripod with you. The entire eclipse takes 3 to 4 hours from the partial phases through totality and back through partial. So if you want to hold your camera that whole time and keep it pointed, that's fine.
That's really zen. That really is.
During totality, it's dark, so you're gonna be doing night photography, and if you don't have a tripod, you're gonna have to crank the ISO way up, and good luck. Could be a really nice blurry photo of the total eclipse because you didn't bring your tripod. But
Instagram's gonna blow up that day, right?
I'm sure there's gonna be a few hot hashtags.
Right,
I might bring I might get put a tracking mount on my tripod and just let the camera track it automatically and just shoot it with a trigger while I look at it through glasses.
That's what I'm saying. You're gonna have let's say do you need your glasses on while you're establishing your frame?
You definitely need it for aiming because even
with the filter.
Yeah, put a filter on your camera. If you try to aim the camera without eclipse glasses, you're going to be looking at a very bright sky, and your body keeps you from staring at the sun. Like there's a reaction.
There's something primal,
there's a mechanism we have to
Yes,
protect us.
It's hardwired into us, so we can't.
Yep.
So
it's like when you touch something really hot.
Exactly.
You don't hang
Except
out.
that this is a nuclear fission reaction that you're looking at. So it's touching the oven to the nth degree.
The challenging thing is you point the camera generally in that direction. You put the eclipse glasses on, you can see the sun, but you can't see your camera. So you're bouncing back and forth. I mean, it is challenging. There's really no. The other solution is you just look through your electronic viewfinder, your optical viewfinder through a filtered optic,
or tethered to a laptop or a tablet or something, and
just start moving the camera around in that general direction until you find it. But it's a relatively small target in a big sky, so it's tough. It's really not easy. So.
Okay, we're going to take a short break, and when we return, we're going to be speaking with Tyler Nordgren. Tyler is not so sure that photographing the eclipse is the best way to enjoy the spectacle. Stay tuned.
We hope you're enjoying this edition of the B&H Photography Podcast. Send us a tweet at BH Photo Video, #BH Photo Podcast.
We are back, and we're with Dr. Tyler Nordgren, who is a full professor of physics and astronomy at the University of Redlands, and he's also a respected night sky photographer. Tyler has written on subjects such as dark matter and galaxies and star pulsation. He was part of the design team that created Mars dials that are on board NASA's Spirit, Opportunity, and Curiosity Mars rovers. He has also worked with the National Park Service to promote astronomy education and is the author of the 2010 book Stars Stars Above, Earth Below, A Guide to Astronomy in the National Parks. Finally, he has designed some beautiful poster art to commemorate the 2017 eclipse. Check it out at TylerNordgren.com. We'll give you that address at the end as well. Welcome, Tyler.
Pleasure to be here.
Great to have you. Rumor has it that you are here to advise us not to photograph the eclipse. Okay, tell us about that.
Well, I have to admit, if you have never seen a total solar eclipse before, the word that I'm telling everyone is see your first one, photograph your second one.
I get that. I really, really do.
Is that really feasible in this day and age, though? I mean, where everyone is snapping and sharing and oversharing.
Well, okay, to be realistic, yes.
Yeah, how do you really emphasize that to people?
I tell people about what the experience is like to actually see a total solar eclipse. It's unlike anything that you've ever experienced before. And odds are, for the average person, there's going to be somebody else photographing it who is a much better photographer than you are. And those photographs are going to be all over the internet. So just get one of those.
So, Tyler, one of your new book is Sun, Moon, Earth, The History of Solar Eclipses, From Omens of Doom to Einstein and Exoplanets. And you mentioned your experience with the 1979 eclipse. So I was wondering if you could tell that to our audience here.
Yeah, I was 9 years old back in 1979, living in Portland, Oregon, and that was the last total solar eclipse to go over the continental U.S., and it went right over my house. And I was already interested in astronomy at that point. But for some reason, all of the news media, everything had me absolutely terrified. And I thought for sure, from what I was hearing, that if I accidentally looked at the sun during a total solar eclipse, I'd burn my eyes out. So my first eclipse experience is actually sitting in a darkened house with all the curtains drawn, watching it on TV. I even photographed it off the TV set with my little plastic camera.
What were your parents doing? Were they outside watching the sun, wondering why you were in the basement?
They were at work. And so it turns out my school had canceled classes that morning because, I don't know, legal reasons. And this is something that's still going on. And I'm part of a task force where we're trying to work with schools and people to say, look, you don't have to be afraid. These things aren't dangerous.
What are some of your recommendations to kids in schools? Because that was also a topic that came up, that schools have to deal with this. So how are you coaching them?
So one of the things we're letting folks know about is that simple little eclipse glasses, those little $1 cardboard glasses with the special silver filters, they're cheap, they're inexpensive. And if you think about all the other safety things we have kids do at school, like football pads and helmets and things, this is far, far cheaper, these little glasses. And if you use these when there's a partial eclipse, it's utterly safe. And if you happen to be in that path of totality, the instant the eclipse becomes total and the sun disappears fully behind the moon, it's perfectly safe. It's no brighter than the full moon at that point. So there's nothing to be afraid of here if you just use some common sense.
Do you anticipate the news outlets being that alarmist as they were back in 79? Because I don't think that they've gotten any less alarmist in the interceding years.
And in fact, there was a total solar eclipse down in Australia back in 2012. And the media down there got it into their head that there was no safe way to view this eclipse. And the local government was putting out the message of turn away. And the astronomers and the folks who knew better had to try to overrule this and said, no, this is the most amazing experience you can ever have, the most spectacular thing you can see in the sky. Don't turn away.
And in your dealings right now, what are you seeing? I mean, are you getting that kind of false information from people regularly?
There are some folks out there who've spread the word that even solar eclipse safety glasses aren't perfectly 100% safe, and that's not true. But it's one of these issues where, for a lot of folks, schools will still be on summer vacation, but for a number of other places, it's going to be the very first day of class. And so the issue is, okay, how do you get that information out there? And if you're on the East Coast, the eclipse is happening there in mid-afternoon, and so potentially you're at the point where all the students are at the school bus or about to leave. So
panic.
The timing isn't perfect.
In general, do you think that most people are going to know this is going to be even happening?
There are astronomers and other folks out there that have been just traveling the countryside. And when talking to folks like state governments in Missouri and Oregon, the officials know. Those folks are aware. And the hoteliers and people operating motels and lodges within the path of totality, their places are booked solid. They've been booked solid for at least a year. So those people know. But it's getting that word out to the general American public saying, hey, 1 hour, 2 hour drive from where you live, there is something phenomenal that's going to happen. I know a lot of astronomers, we were expecting that at this point, the media would really have picked up on this. But I don't know. I guess the media has been preoccupied with something else going on.
Yeah, those Mets, boy, let me tell you.
Yeah. Where are you going to be, Tyler?
I'm going to be up in Eastern Oregon. You take a look at the weather forecast. There's an astronomer by the name of Jay Anderson. He's up in Canada, works for the Weather Bureau up there, and he's published these amazing maps going back historically, looking at what the weather at the appropriate time on the appropriate day is for places along totality. And really the best places with the highest probability of virtually clear skies is out in Eastern Oregon, central Idaho. So I've still got family up there in Oregon, so that's where I'm going to be.
Am I hosed down in Nashville?
No, well, okay, you're not completely, and you're there the mid-afternoon, and so one possibility is, and here's something that's really neat. An eclipse is caused by the shadow of the moon, the shadow of the moon moving across the U.S. And in that shadow, the temperature drops. And when the temperature drops, it creates its own weather. So I've been to eclipses where it was completely cloudy. And then as you came on towards totality, the heavens just opened up and everything got completely clear.
Cool.
So it could happen.
Interesting.
And you're advising, not necessarily advising, but I think everyone totally understands your point about enjoy the spectacle, but will you be photographing it, and what's your setup going to be?
I like that laugh. Okay, here we go.
Yeah, I'm probably going to take a camera, but what I'm going to do is I'm really going to be interested in just seeing this for myself. So the camera that I've got a Canon 5D Mark III with a very wide angle lens. It's a 15 millimeter, and so it's almost a fisheye, and so it's going to be the kind of thing that I just plop down. I'll set the timer on it before totality, and let this thing just snap images of the countryside, the people, the location, and that's going to be the special thing.
Are you going to have a solar filter on or anything?
There will be I'm going to have a special filter that I built, that I bought from solar eclipse material that I put into a frame to go over the lens.
Oh, so you are filtering it. Yeah. Okay.
Yes. And that's the thing I tell folks too, is that just to be on the safe side, I don't want any sun going into the lens of my camera if I wouldn't have it going into the lens of my eye. So during the partial phase, I'll have that filter on. Right when you get to that first diamond ring, and that diamond ring is when you get this pinpoint of light from the last little speck of the sun disappearing behind the moon. And so you get one last ray of sunlight traveling down through a lunar valley right there on the edge of the moon. And so you get this pinprick of bright light around this black circle with a white ring around it. And at that point, that's your signal that it's safe to take your filter off, or you take your glasses off. So I'll just pop the filter off at that point and have the thing photograph away while I'm just looking at the sun. There's folks I've heard of who in previous eclipses didn't realize that during totality, between those two diamond rings, you actually have to take your eclipse glasses off. Those eclipse glasses, they dim the sun's light down to a safe level. Well, it's already dimmed to that level during totality. So if you don't take your glasses off, or you don't take that filter off your camera, you'll see nothing.
Right. People will be like, I came all the way for this.
I don't know what the hype was about. Yeah. That was really a letdown.
I didn't see nothing. It was boring.
So can I ask, where would you advise your average Joe like myself to kind of find information as to where would be a good place to go? Let's say you're a city dweller and you want to get 2 hours outside of the city. Any thoughts on that, or any websites you can recommend?
Yeah, probably one of the best websites out there is greatamericaneclipse.com. That's operated by Michael Zeiler. He's an expert on geographical information system. And he's got these incredible maps that show things like the average driving time from any location in the U.S. to the path of totality.
Can I ask for people who will not be in the path of totality, and let's say in New York where we're at 71%, did you say?
Yeah.
Will it ever be safe to look at?
No.
What's the percentage where it is safe? Only
It's
in
totality,
Yeah.
100%. That's the only percentage.
So if it's not totality, you're not looking at. Okay, got it.
You would need glasses.
Correct.
Yeah.
Even for
Correct.
an annular eclipse, you probably don't ever take the glasses off. Is that correct, Tyler?
That is absolutely correct.
Okay. Yeah.
The only time it is safe to look at the sun without any kind of filter or aid is during totality in that 100% coverage.
Can you speak a little bit about what maybe compare this eclipse with others that you've seen and what makes this one special and different, and even compare it to the one that's scheduled for 2024?
The thing that's really special about this one is it's going from coast to coast over the United States. The last time that happened was in 1918. So we're talking 99 years since the U.S. has had a coast-to-coast total solar eclipse. And it's been 38 years since the last time the continental U.S. even saw one. So the really big thing that I'd say that's happening this year is this is the first major continental-wide total solar eclipse in the age of social media. So not only do we have 12 million people just living in that path of totality, we have the millions that are going to be traveling into that totality in addition, and every single one of those people pretty much is probably going to have a camera on their bodies, maybe just in the form of their iPhone. But this is going to be the most photographed, the most tweeted, the most shared, the most Instagrammed event in human history. So that right there is going to put this eclipse at the very top of the list of most seen eclipses, most experienced eclipses in human history.
To show you how much of a nerd I am, you saying that, I got goosebumps. that this is going to be the most shared and photographed eclipse in human history. Literal goosebumps.
And I thought it's because you were sitting next to me. Jeez. Okay.
That ship has sailed, Alan.
And what about other countries? Where does it go from here? I guess out to the Atlantic.
And that's the other thing that's unusual about it is totality goes nowhere else.
Yeah.
It starts in the Pacific Ocean. It ends in the Atlantic Ocean. The U.S. is the only country getting totality for this eclipse.
It's a fleeting moment, really. Yeah.
And please, nobody make a joke.
That hasn't even happened since I think back in 1776, before we were even a country.
Wow.
That went from shore to shore.
How many eclipses have you seen? Have you traveled to?
I've traveled to, 3 total solar eclipses. So I'm a relative newbie in this field. But I saw my first one in 1999. I was a brand new PhD astronomer. I was at a conference in Budapest, Hungary, on variable stars, which was my research at the time. And as in the middle of the conference, they bussed us down to the path of totality for the 1999 eclipse. And after 20 years, it'd been 20 years since that experience as a 9-year-old, I looked up and it changed my life. The hair stood up on the back of my neck. I can say I honestly experienced awe at that moment.
Did you take a picture of it on the TV?
No. No.
Did you take a picture in your first eclipse?
So I did photograph it. I did not follow my own advice.
But he did not tweet it.
photographed
He did not tweet it in 1999.
Did not tweet it.
Okay, cool.
But one of the things I'd done is, so I was using my camera that I'd had from high school. It was an old Canon AE1 program. I had a 200 millimeter zoom lens with a 2x teleextender on there. And I experimented. I sat down and trained myself in the months leading up to this. I was using slide film too. In the months leading up to this, I made sure that I could snap photos, change exposure times, do everything without drawing my eye away from the eclipse.
Well, that's something we were talking about earlier, just for people to practice ahead of time.
Yeah.
That's it, because totality only lasts for about 2 minutes and 40 seconds tops. So we're talking 160 seconds here. You do not want to spend a single moment of that 160 seconds futzing around with the menu on your camera or the focus or any of that.
Good information. Tyler, thank you so much for joining us today and giving us more insights. And again, for our listeners, you want to check out, if you want to check out some of the incredible things that Tyler is up to, you could go to his site. That's TylerNordgren.com. If you can't understand the way I said that, it will be very legible on our website. Just go over to Explorer and on the podcast page, and you could catch up on all the stuff about what Tyler's doing, his websites, etc. Again, Tyler, thank you so much for joining us today.
Hey, it's my pleasure. And if I may here, I would like to read something.
Please.
This is from the 1862 total solar eclipse, which was the first to be photographed by Warren de la Rue. And here is what he wrote in his scientific paper presenting his photographs after the eclipse. He said, "When I had once turned my eyes on the moon encircled by the glorious corona, then on the novel and grand spectacle presented by the surrounding landscape, I mentally registered a vow that if a future opportunity ever presented itself for my observing a total eclipse, I would give up all idea of making astronomical observations and devote myself to that full enjoyment of the spectacle which can only be obtained by the mere gazer." Oof. So if that was the first man to ever photograph a total solar eclipse, I want to leave that for your listeners.
Wow. Boy, talk about good sign-offs. Thank you so much, man. Okay, that's it. Show's over. That's it. Okay, Tyler, thank you so much for and a great way of ending this portion. Thank you so much again.
Hey, it's my pleasure. Thank you, guys. This was a lot of fun.
Have a great day.
Okay. Thank you. Welcome back. Dr. Laura Petit is a senior fellow at the Space Sciences Laboratory at the University of California, Berkeley, and director of Multiverse, the Space Sciences Laboratory's educational group. Laura is an expert on the Earth's aurora, but has turned her attention to education and outreach and has led several NSF and NASA-funded national education programs and is currently leading the Eclipse Mega Movie Project, a crowdsourcing effort to collect and share images across the path of totality during the 2017 total eclipse of the sun in the United States. Welcome, Laura. Please tell us about this mega movie. This sounds pretty interesting.
The idea is that we have this amazing opportunity for the first time ever to have the public provide photographs of a total solar eclipse across an entire hour and a half of the eclipse happening. So this is really it's a once in a life. We will have another opportunity in 2024. However, that eclipse will go from kind of up through Texas and Carbondale, Indiana, and all the way up to Canada. So it's not a coast to coast, but more a south to north eclipse. And this is so we have this amazing opportunity right now, and with the kind of cloud technologies to gather these images and not only that, but then to share them back out with the public.
How are you going to output these? What do you have an idea what kind of form you're going to be doing this in, or are you waiting to see what you get? I'm trying to imagine what a film of the eclipse is going to be like. There's so many ways you can do it.
Yes, there are many, many ways, and we're really starting to narrow down on what it is we're going to produce. The first thing that we'll produce is a movie from our trained volunteers who will be using DSLR cameras across the entire what's called path of totality, which means that these folks taking photographs are actually in locations where the moon will completely cover the disk of the sun. And so we'll be able to see the outermost atmosphere of the sun called the corona.
Around how many people are involved in this part of the project?
We'll have about 1,000 volunteers.
Okay.
And we're getting close to that number. We have about half right now.
Do you have parameters for the kind of camera that they're using or the lenses that they're using? Is there any standardization for how they're taking the pictures?
There is some standardization in terms of the resolution of the data and also the amount of the sky that we want. And so really people can use a wide variety of types of cameras as well as lenses, but if they have a certain megapixel camera, then the lens that we would like them to use or the zoom would be a little different. So we have a kind of a calculation for people to use with
so
that.
What you're really is you're looking for a lens, no matter what the format is, that takes in a certain angle of view. So there's a little bit of consistency. Is that what you're getting at there?
Yes, exactly. That is exactly what I'm getting
Now,
at,
this is open to photographers and videographers, or is it only still?
We're really focused on the still image, in part because although movies are incredibly helpful as scientists, when we really want to do quantitative analysis, we really want the still. And the more stills we have, the more we can kind of understand what the calibration needed is, and we can determine brightnesses and some more quantitative calculations.
So one of the only constants that you're going to have is, the way I'm seeing this, is going to be the sun and the moon and their relationship together, and everything that's going to change based on where you are in the photography is everything else around it, the surroundings. Is that correct?
Yeah. Yes, that is pretty much correct, which makes it a really cool challenge. And our skeptics feel that what we're doing is impossible, of course. And then our team knows that we can do it, and we have a plan for how to do it. And on top of that, we now have an app that will come out and add to our data. And the more data you have, no matter how kind of crude it is, if you have more of it, you can pull kind of this what's called signal to noise out of many different pieces of data. And so we're really looking to get as much data as we can.
What kind of data are you pulling from the app?
Well, the cool thing now about phones is you can actually get counts per pixel. It used to be that you could only get as an output, like a JPEG or an image file, but now you can actually determine how many photons hit a pixel on your camera, on your phone.
Can I ask what's the end goal? What's the goal of all this data and photo collection? Just to make the video, or is there a scientific purpose?
Yeah, so there are three. I'd say there are three goals. One is scientific. We really want to understand more about the dynamics between what's called the photosphere of the sun, which is that bright disk, and the corona, which is out further, because unlike, say, a flame, which gets cooler as you get away from it, the sun actually gets hotter as you leave the bright surface. And why that is still an unanswered question. We have good ideas that it's connected to magnetism and electricity and particle acceleration, but we really need more information. And the Eclipse provides a really nice what's called white light data from this transition region, the boundary in the part that's going to heat up the corona.
Are there any big questions that this is going to answer for some people? Because back in the 30s, I think it was, Einstein's theory of relativity was proven during a solar eclipse, and it was the one thing they needed a solar eclipse to prove or disprove
gravitational lensing.
Thank you, Todd.
Yeah.
I was going to say that.
Are there any big science questions that people, because this is transiting the entire nation and we have so much time to photograph it and gather information about it, that this is the perfect opportunity to answer X question?
Well, I think the X question really is about the heating of the corona.
Is anyone's Nobel Prize on the line for this?
The only Nobel Prize that could be possible, although my astrophysics colleagues may scoff at this, but again, people scoffed plenty at Einstein's general relativity equations. But so,
I told them to get a day job.
Einstein. Yeah, I'm not claiming any brilliance here, but we do have this question of both dark matter and dark energy, which of course is much grander scale in terms of kind of galaxy scale and beyond. But just thinking about this question of the gravitational lensing and gravity, there's something we don't understand about gravity. And who knows, that maybe that there's going to be enough data at a high enough resolution that there may be something we can kind of pull out of there.
that's fascinating.
Is there a website or a place people can go to? So listeners are listening to this right now. Our listeners are getting all excited and they go, okay, where can I find out more? Where can I go? I want to join up. I want to help out. Where can people go right now?
So they can go to our website, absolutely, and it is eclipsemega.movie.
And
Okay.
are you still looking for volunteers? So you said you seem to be looking for people still, or no?
Yes, we are still looking for volunteers. And not only that, but if people, if they don't want to sign up and be formal volunteers and be part of our training and be part of the big community that we're building, people can also they can sign in with a Google login to the site. And in order to become a trained volunteer, then after you do that step, you need to fill out the form on our website, and then there will be a button that says apply. And then to apply, then you have to click on that and fill out an application form to be one of our trained volunteers. If you don't do the apply step and you log in with a Google sign in, then at that point, once you've taken your own photos in your own way, we will collect any and all of those that people want to share with us.
Now, is this only photographs of the eclipse in its totality, or are you also going to be going for the variations and the gradations?
Only totality. That's correct.
Okay.
And you mentioned Google. How are they involved?
Google is really making this all possible. So about 2 years ago, they got excited about the idea and started becoming more and more involved. And at this point, they are responsible for hosting the website.
Do they have that technology?
yeah, there's something about that. They're also responsible for running an algorithm that one of our team members had developed for making the movie, which they're refining and updating with some interns support from the Oregon State University, some undergraduates from there. And they are also responsible for, on the website, for example, gathering the data and also sharing that data out. So we're working on a plan for archiving the data for scientists and the public.
When would the movie theoretically be finished? Is it something that's going to be almost right after the fact? Is there that kind of technology involved? Or is it something that's going to need an editing and it's going to take months and then get together as a final project?
Yeah, so we're going to do both. The first movie will come out about 2 hours after the eclipse, and
that's a quick turnaround. That's interesting.
Quick turnaround. Let me tell you.
Will that just be raw? Just everyone's raw footage?
No, there will be processing. So all the circles will be made the same size. And we're also going to use Regulus, which is a fairly bright star that should be in the field of view for most of the images. We're going to use Regulus to rotate the images to be in the correct location. And then, so those are the two processes that we'll be using and luckily we're using the Google servers to do all that in real time.
Who is going to be doing this editing and this compiling?
We have a computer algorithm that we have been that we developed a couple of years ago, and now one of the Google team members, Dave, and his interns, he's been doing a great job and working with our scientists and some computer scientists to make some modifications to the algorithm, and that's in GitHub. We're doing everything open source, which basically means it's a public domain, so that Google doesn't own it. The University of California doesn't own it. We're really working to make sure this is a public project.
That was my question. And how will people be getting their images to you? Is there an FTP or website?
There's on the website. If you log in, then there will be shortly a uploading feature.
Is Google or are you or anybody else actually going to be starting a large campaign to make people aware of this? Because we're getting close. And again, this is the first we've heard of it, and we've been pretty busy here with eclipse-related information. So how is this project going to be put out to the public?
Well, we've been working at it. we've been doing a tour across the path of totality, where we do town halls with the public and with the city and county offices and many different organizations in many different states and cities. And we have one more in Nebraska coming up. So that's been kind of our grassroots effort. And then we've been writing articles. We've been reaching
doing podcasts.
Doing podcasts, exactly.
It's all downhill from here.
I don't know why you know that. Yeah, so we're doing our best to kind of get the word out through all our networks. We've talked about putting ads out in newspapers, and but and also Google's really good ethically in terms of not. They can't promote their own things on the Google search.
Right.
And so they have. So we get to play with all the rest of the world in terms of marketing. And
when you do community outreach, like when you host a town hall to give communities the word, how is it being received?
People from institutions that never talk to each other are really talking to each other. Like the scientists are talking to the city officials. That doesn't happen very often. Educators are talking to the scientists and the county and the public. Just members of just folks who work in the city in various service-oriented fields, or they're showing up and just curious about what's going to happen and why, and they want to be able to tell their families. And
can kids be involved?
Yeah, absolutely. I mean, I think an adult for the volunteer photography piece, it's complicated enough that probably it'd need to be like a parent or adult kid pair.
Right.
But absolutely, and that mentoring type of situation is always fantastic.
I was thinking it's perfect for like, Boy Scouts, Cub Scouts, that kind of thing. Like
yeah, no, absolutely.
Where are you going to be, and what are you going to be doing during the eclipse? I imagine you're going to be busy gal.
Yeah. No, it's a good question. My family was trying to set up a family reunion during the eclipse, like many families, and under the path of totality. And then I realized, I'm part of this. I'm leading this mega movie project. I can't desert my team, so I deserted my family.
So, will you be in Oregon? Where are you going to be traveling for it?
So I will be in Wyoming, in Du Bois, I think Du Bois, Wyoming, and we'll be with the team, the mega movie team. A big chunk of us will be there, and we'll be taking photographs and experiencing it and getting ready to get the movie together.
What if it's cloudy, Laura?
I'll cry.
I will too.
Nobody's saying that C word. It's like, no, we don't want to know about this. No kibosh.
But then, I'll pick myself up and I'll take pictures of the clouds and send them to the cloud folks who want my data from clouds.
Are you going to be using this as sort of a beta test for the 2024?
Yes, absolutely. Yeah, no, that is the plan for many of us on the team. I think we'll have to prove ourselves to some degree, right? We really will have to come out with a movie that's compelling, and as well as have this beautiful archive. But absolutely, we're going to learn, because this has never been done, and we're going to learn so much. So we'll be able to take all that stuff we learn and apply it. Mm-hmm.
I have a crazy question. Is this going to be in IMAX? How are you distributing this mega movie? Is it just going to be streaming online? Will it be in theaters? Can you turn it into a Disney ride and walk on the sun with it? What's the distribution plan for it?
Well, the distribution plan for the movie that comes out a couple hours later is it will be on the website for people to download. And then we really want news organizations and education. I mean, really anyone to be able to have access to that and use it in any way they find useful. And then I think, we have a film documentary person on our team, and he's been filming we've been working on this project for 6 years, and he's been kind of filming the team. I mean, he has been filming the team and our meetings and going to he's an eclipse chaser already, and he's been filming eclipses. And we're also kind of looking for some additional funding for him to really produce a documentary about this whole process and the project. So in my big dream of how this all plays out, then there's kind of a behind the scenes movie that goes with all the movies that will get produced with the data.
That sounds fascinating.
Yeah. Sounds great.
Okay, Laura, thank you so much for joining us today. This has been very, very informative.
Can you throw us the website one more time for people to go to find information?
Yeah, it's eclipsemega.movie.
And that will appear on our website when this episode goes live. You'll be able to go to our podcast landing page, and all the information will be there.
Laura, is there anything else you wanted to add that we didn't touch on?
No, I just want to really thank you all for this podcast and the opportunity to share this project and share my passion for it. So thank you so much.
Thank you.
Thank you.
Thank you, Laura.
Great stuff.
All right, Laura, thanks again.
Well, that's a wrap on another great show, and be sure to stick with B&H Explorer in the lead up to the solar eclipse, as we will be publishing many articles and updates about this historic event, and of course, selling the gear you will need to safely view and record it. And with thanks to John Harris and Jason Tables, I'm Alan Weitz, and as always, thank you so much for tuning in today.